So PLA stands for Programmable Logic Arrays. So in this, both are programmable. Inputs AND gates are programmable. Output OR gates are programmable. The meaning of programmable is already known. It is flexible while providing the inputs. Means you're going to represent that as a star across all these input points. Means whichever the one it is required, you can connect only that particular one. So inputs are programmable, even the outputs are programmable. So just for the sake of example, I've written that some 3 AND gates and 2 OR gates. If I want to write it all 8, you can write down all 8 AND gates. Multiple OR gates you require, you can write down multiple OR gates here. So whichever the input is required for you, you connect only that particular input to be connected for that AND gate. Whichever the output, like in this output of this AND gates, whichever is required, you connect only that particular one for the OR gate. So using these, we can able to design the circuit with the programmable logic arrays. So in the PAL, it was different, right? This was programmable, here it was fixed. So first you need to decide how many inputs. Based on that you are fixing it. Now it is programmable. So you are free enough to provide the inputs for your OR gate. So now we'll go back to the same problem which we discussed in the last class, and we'll solve that problem using PLA. Same problem. This we have solved with PAL. In the exam and the test also you can get a question like simplify this problem using PAL and also PLA both. So the same steps, whatever the functions given, use the K-map, simplify these expressions. Once you simplify, you will be getting the simplified expressions. Okay, these are the expressions. So now circuits are different. So once you write this expression, still here it is same. In the PAL, we have written a table that was different now when compared to your PAL. We'll just do that. So now the program table, you need to write down all the product terms. There is no repetition. And here you write down the inputs. Here you write down the outputs. So inputs are A, B, C, D have written. What are the outputs? We have 4 functions there, right? W, X, Y and Z. These are the 4 functions. So what do we write now here? A bar, B bar, D bar means 0, 0. C is not there, so dash, D bar 0. So this was there in W, correct? And also in X, correct? No? Then in these two it is present. So write 1 1 for this. Y and Z it is not there. So dash, put a dash for this because it is not there in these two terms. Then A bar, B, C. A bar is there, sorry 0, B 1, C 1. D is not there, put a dash. It is there in W and X, put 1 1 for this. It's not there for Y and Z, put a dash. A C bar, A 1, C bar, sorry, it should be dash. C bar 0, dash. Then it is there in W, it is there in X, and also it is there in Y. Is it Y or Z? Yeah, it's there in Y. So write down that it's there in Y, but it's not there in Z. Like this, you should write down this content. So dash, B is there, C is there, D bar, so 0. This is not there in W, it is there only in X, it's not there in Y, it's not there in Z. You got this point? This is how you need to write it for all the product terms. And write down all the inputs, whether it is 1 or 0 based on whether it's a variable or a complement of the variable, and also write down whether this term is there in what function. If it is there in some function, write 1. If it is not there in function, then write dash. So like that you should write down the contents in this program table. Since this problem is quite bigger, you have many terms here. Otherwise, you will be having less number of terms only. So, but you have to list out everything. A bar, B bar, D bar. So, A bar, B bar, D bar, how you connect? All complement. That's you already written, right? Wherever you have written 0. So, it is bar. So, A bar, B bar and D bar. This is the first term. So, this term, according to the program table, it's been put 1 for W. It's been put 1 for X as well. Put the star for this also. Got it? Check for the second row there. Second row were A bar, B, C. A bar, B and C. A bar, B, C. This is A bar, B, C. This term also put 1 for W. We have put 1 for X, means this term is there in both. Put a star for that. Then third row. Third row is A, C bar. A, C bar. So A, C bar. For this we put in 1 for W, we put in 1 for X, we put in 1 for Y. Put a star for all this. Fourth term is B, C, D bar. So B, C, D bar, B, C, D bar. In this we have not put 1 for W, so don't connect. We have put 1 for X, you connect this. Not put in X for, 1 for Y and Z. We have not connected all these things. Like that, go to the next column. Next column is A bar, B bar, C. So A bar, B bar, C. So this term is not there in W. Don't connect here. Not there in X. Don't connect here. But it is there in Y. You connect this. Got this point? Like this, you should go through your program table or what you have written there. Every row, wherever you put 1, only those connections you put it in the output side. Whatever the terms you have written there. If you have written 1, so connect directly that variable. If you have written 0, connect to the inverter output of that variable. Like that, you go row by row in that program table and do the circuit connections. It's not completed yet. You have so many things in between. You should connect all those and then connect appropriately for these outputs as well. Then only the circuit will be completed. Here it is incomplete circuit only. So we'll just discuss the difference between PLA and PAL. So what is the difference now? PAL, R is fixed and is programmable, R is fixed. PLA, both and R are programmable. That is the one difference. So next, I can implement any SOP function using PLA, any SOP using PLA, any SOP using PAL. Because this I can't tell this as a difference. This is similar to both of that. Any SOP expression we can able to implement using PAL and PLA. Next, with respect to the cost, which is more cost here? PLA is more cost because even these are fusible, it is costlier. PAL is cheaper when you compare with this PLA because it is fixed, it's not a programmable. The cost will be less in PAL. So PLA is costlier and this is more complex also. But here you feel like it's very easy, you can just put a cross mark. But you have to look in that if any terms are there, whether you need to write those terms, repetitive terms in any of the functions, like that you have to look into all those things. With respect to that, it is little complex since everything is easily connected over there. But in the same problem we discussed in the last class, this AC bar we connect it with the same. This is how you can do it. Otherwise, you can just have one more AC bar implementation and you can do it. So there you will be having less confusion over there. So here you need to care with how to connect with the PLA. So this program tables are different in both of this. Because here with respect to the product terms you are going to create the table. There with respect to each expressions you are going to create the table. Yeah, I think these are the differences between PLA and PAL. Any doubts regarding this? So the question now is, you have to implement with the PLA 3 cross 4 cross 2. The meaning is 3 inputs, 4 terms or 4 AND gates, 2 outputs or 2 functions which you need to implement. So these are the 2 expression given, means these are the 2 functions. So the name here is AB. These are the minterms given and these are the inputs given, X, Y and Z. Means 3 inputs, these are X, Y, Z. 2 functions, this A and B. Now this is being asked with 4 AND gates. Only 4 AND gates you have to use it. So now we need to implement this problem with PLA, Programmable Logic Arrays. So first simplify this problem. Draw the K-map. So this is for A. This is for the function B. Okay. So write the entries into the K-map 0, 1, 3, 4. It's been written. And do the grouping. So we get the expression for A is, so Y bar Z bar and X bar Z is the expression for A. For B, we have an expression. We write the entries in these locations as 1. So 1, 2, 3, 4, 5. So we make the grouping here. So we get 3 terms here. So for this group, X, Y bar. So X, Y bar. For this group, X bar Z. For this group, X bar Y. These are the terms now. Now, if you just compare these terms with this, it's been asked here 4 terms. But how many terms we have total together? 1, 2, 3, 4, 5 terms. Just look into these. Is there any repetitive term here? Yes. X bar Z is repeated in both A and B. So if you just reduce this 1, then it will be 4 terms. So it satisfies this problem. So directly we can draw the program table now and put the entries into the program table and start implementing. Only this term is overlapping between these 2. So when we realize this term, connect for both A and B. So other terms you just connect only for A here for Y bar Z bar. This you just connect only for B. Like that you can draw the circuit and do the connections. Now, so while doing the grouping, you should ensure that you will be having 4 terms only. So in this problem, there is possibility of getting 3 terms. So, but when we want to group this one, this is the only option you should do that grouping, that is X, Y bar. In order to group this, this is the only option we have to do that, that is X bar Y. But now for this one, we have 2 options, either group here or group here. So if I group it here, I'll be getting the answer as X bar Z, so that is repeated over here. So this is the best possibility. So do this grouping. If you group like this, then we will not get any overlap term between A and B. Then we can't satisfy this option, this criteria of 4 terms. So that's the reason you do this grouping instead of this. Then we need to draw the circuit now. This is the program table for that. Y bar Z bar. So 0, 0 in these locations, there is no X dash, and this term is there only in the function A, it's not there in B. X bar Z, so X bar 0 dash 1, it's there in both A and B, put 1, 1 for this. X Y bar, so X1, Y bar 0, and there's no Z, it's there in only in B, we put 1 for this. X bar Y, 0, 1, we put 1 for B, it's there only in B. Now we need to draw the circuit for this. So column by column, row by row, Y bar, Z bar, so you connect this Y bar and Z bar, that is 0, 0, we have written in place of this, and this term is there only in the A function, so put a cross mark for that. X bar Z, X bar Z, this term is there in both A and B, put a cross mark for both of this. Then X Y bar, so this, it's there only in B, put a cross mark for this. Then X bar Y, it's there only in B, put a cross mark for this. So this is what the circuit for the problem. So like this we can solve this. So with this I'll wind up this session. Thank you.